Hi friends, in this video we are studying material science objective question and answers part 1. So let's start. The material in which the atoms are arranged chotically is called amorphous material, mesomorphous material, crystalline material, none of above. So here we have to know the meaning of this word. So that means atoms are not arranged in a systematic order. So the chotically means atoms are not arranged in a systematic order. So the question is the material in which atoms are not arranged in systematic order is called as amorphous material. Therefore option A is correct option. Crystal structure of a material is generally examined by naked eye, optical microscope, metallurgical microscope, X-ray technique. So, crystal structure of a material is examined by X-ray technique. Therefore, option D is correct option. An example of amorphous material is brass, glass, silver, lead. So, here amorphous material is one which there is no definite atomic structure and atoms exist in random pattern just like in liquids. So, examples of amorphous material are coal, coke, glass, plastic, rubber, etc. You can see here in the diagram. So, the single crystalline materials have periodic across the whole volume, while as polycrystalline material periodic across each grain but not over the whole volume, whereas amorphous solids are not periodic. Therefore, we can answer here glass is a amorphous material. Therefore, option B is correct option. Crystal structure of brass is FCC, BCC, HCP or orthorhombic. So here brass is a metal alloy made up of copper and zinc. The proportions of zinc and copper can be varied to create the range of brasses with varying properties. It is substitutional alloy. Atoms of two constituents may be replaced with each other. That means we can vary the proportion of zinc and copper so to produce the brass. And the crystal structure of brass is body centered cubic. That you can see there is a atom in the middle and covered with the atoms of copper. So zinc atom is in the middle and copper atoms in the outer shell. Therefore, option B is correct option. Dislocation in material is dash defect, point defect, line defect, plane defect, volume defect. So here the line defect is known as dislocation. The line defect itself is known as dislocation. So when they are telling dislocation, that is obviously line defect. So the schematic diagram of the dislocation of line we can see here. Therefore, option B is correct option. The coordinate number of BCC crystal structure is 8, 16, 12 and 10. So, coordinate number is called as legacy. The number of atoms or ions or molecules that a central atom or ion holds as its nearest neighbors in a complex coordination compound or a crystal. That means the number of atoms holds in its nearest neighboring complex. See here, there is a center on atom is here, So coordination number is number of atoms it holds in that crystal structure. So in the BCC it holds 1, 2, 3, 4, 5, 6, 7 and 8. Therefore, the coordination number for BCC is 8, whereas for FCC it is 12 because there are 8 atoms in the edges, whereas there are another 6 atoms on the base. So totally it is 12, whereas in HCP these are 12 atoms. Therefore, here the question is coordination number of BCC. So that is 8. Option A is correct option. What is the volume of FCC cell in terms of atomic radius? 12 r cube, 16 r cube square root of 2, 6 r cube square root of 2, 16 r cube. So the volume is the atoms touch. So the total volume, we have to find the total volume of the FCC cell. So we have a FCC cell in which we have to calculate the volume of atoms. That means how many atoms that a FCC cell can be filled with. So here we can see, let's write the edges as A and A. So we know volume is equal to length into breadth into height. So it is cubic, so we can write A cube. So here the diagonally we have half the radius, so that is R. There is one full radius, that is 2R, and there is another half radius. So that is equal to R plus 2R plus R, that is equal to 4R. And these edges are A and A. So from Pythagoras theorem, we can write that A square plus A square is equal to 4R square. So A will become 2R square root of 2 because A square plus A square is 2A square. So when we find the value of A, it will become 2R square root of 2. So we know volume equal to A cube. So when we cube this, so 2 cube is 16 and cube is R cube here. So square root of 2 as it is. Therefore the answer is 16 R cube square root of 2. Option C is correct option. Option B is correct option. Surface imperfections that separate two orientations that are mirror image of one another is called stacking fault, grain boundary, tilt boundary, or twinned boundary. So they are asking here, it is a surface imperfection that separate two orientations that are mirror images of one another. So when we see the grain boundary, here we have twin boundaries. So grain boundary, there are three subdivisions. First one is high angle grain boundary, second one is low angle grain boundary, and third one is twin boundary. So the answer is twin boundary because twin boundary here mirror image take place. See here BCABC is mirror image of PCABC. So twin boundary is correct option. But we have to take care here that it comes under grain boundary. If we answer grain boundary as correct option, that is wrong because it is coming under twin boundary because they are telling that mirror image. In grain boundary there are other two options, those are not come under mirror image. Therefore option 4, that is twin boundary, is correct option. Which of the following regions of the electromagnetic spectrum would be used to determine the structure of crystalline solid? Microwave, infrared, X-ray or visible. So here electromagnetic spectrum, that is EM, is the range of all types of electromagnetic radiations. So here we have a table for radio waves. We are using it for the broadcasting and communications and satellite transmission. So radio wave is a electromagnetic radiation which is used for broadcasting, communication and satellites. Similarly, microwaves are used for cooking, communications, satellite transmissions, whereas infrared is also used for cooking, thermal imaging, short range communication, optical fiber television, remote controls and security systems. So here X-rays that we are using in to determine the structure of a crystalline solid. So X-ray is the correct option, that is option C. See here, X-ray is used to observing the internal structure of objects and airport security scanners, medical X-rays. Therefore option C is correct option. The defect responsible for phenomena of slip by which most metals deform plastically is known as fracture, twinning, dislocation, strain, hardening. So here they are asking the defect responsible for phenomena of slip by which metals deform plastically. So phenomena of slip is a dislocation. Therefore option C is correct option. Whereas twinning is not a dislocation, and moreover slip is a plastic deformation. Slip is a plastic deformation. Therefore option C is correct option. When atoms are displaced in two separate planes perpendicular to each other, the defect found is known as edge dislocation, screw dislocation, stacking fault or Scotty defect. So here edge dislocation, this is edge dislocation here, this is normal, and here we can see the dislocation of the edge. In here what happens is an extra plane of atoms can be generated in a crystal structure, straining to the breaking point the bonds that holds the atoms together. So this is edge dislocation, whereas screw dislocation, it comprises a structure in which helical path is traced around the linear defect, that is dislocation line, by atomic planes in the crystal lattice. So here in screw dislocation, a helical shape curve is formed, whereas stacking fault, the stacking sequence produces a hexagonal crystalline, a layer on a loop of B layer. Here we can see here a perfect crystal is here, and perfect crystal, the stacking sequence is ABC, ABC and ABC, whereas it stacking fault, the stacking sequence has changed to ABA because it used to be ABC here for a perfect crystal, but it has changed to ABA. Therefore this location is called stacking fault, whereas Scotty defect is a point defect. There are missing atoms in certain points, so it is a point defect. So as per the question, when the atoms displace in two separate planes perpendicular to each other, therefore this type of dislocation is known as edge dislocation. Option A is correct option. The effective number of lattice points in the unit cell of simple cubic body centered cubic, base centered cubic space lattice respectively are 1 2 4, 1 4 8, 3 2 1 or 1 2 6. So effective number is the number of atoms that can be covered in a simple lattice. See here, a simple lattice, there are 1 2 3 4 5 6 7 and 8. There are totally 8 atoms covering 1/8 of its volume. Therefore 8 corner atoms, those are covering 1/8 of its volume, because there are no full atoms in the lattice. They are just covering 1/8 of their volume. The volume is only 1/8. So these are 8 atoms. Therefore the effective number of simple cubic is 1. Whereas in diagram C you can see here body centered cubic, there is one atom in the center. So this is 1 plus 8 atoms in the corners that are covering 1/8 of their volume. Therefore 8 into 1/8. So this will become 1 plus 1, that is equal to 2. In FCC of figure B here you can see there are 8 corner atoms, those are covering 1/8 of its volume. So that is 1, and 6 space centered atoms, 1 2 3, and backside there are 3 more atoms that we cannot see in this diagram, but there are atoms, another 3 atoms, those are covering half of their volume. Therefore 6 space centered atoms covering half of the volume. So this is equal to 3. So 1 plus 3 is equal to 4. So the effective number is 4 for the base centered cubic. Therefore the option here 1 2 4 is the correct option, that is option number A. Match the list 1 elements with the list 2 crystal structure. So here the answer is 2 4 1 3. So alpha iron is a body centered cubic crystal structure, and copper is a base centered cubic crystal structure. Zinc is a hexagonally closed packed, and glass is a amorphous material. Therefore option is 2 4 1 3. The ratio of elastic strain energy of an edge dislocation is 1 minus nu 1 upon 1 minus nu 1 plus nu upon 1 minus nu 1 minus nu upon 1 plus nu. So the ratio of elastic strain energy of edge dislocation is 1 upon 1 minus nu, that is option B is correct option. Which one of the following is correct for Burger's vector screw dislocation? That is, Burger's vector screw dislocation is perpendicular to the dislocation line, inclined to the dislocation line, parallel to the dislocation line, and opposite to the dislocation line. So screw dislocation Burger vector is parallel to the dislocation line, whereas edge dislocation is perpendicular to the dislocation line. So here they are asking for screw dislocation of Burger's vector. So that is parallel to the dislocation line, that is option number C is correct option.
If you have any questions or comments, text in the comment box, and don't forget to subscribe, because subscription is free and also you get the notification of upcoming videos. And please like and share. Thank you.